All right, here we go with the second part, part 2 of section 1.5. We're still talking about parent functions, but now we're going to talk about transformations. All right, so we did talk about this a little bit in Algebra 2b. This is a little bit more in depth. Same information, but a little more in depth. So the essential question is still the same. What are we trying to learn? What are transformations of the parent functions, and which ones are the most common? Okay. So that's what we're trying to figure out. And what we're going to learn is how to identify and graph transformations of parent functions. All right. So first we need to know what a transformation is. Okay. So transformations of parent functions can affect the appearance of the parent graph. So a transformation is something that changes the appearance of a graph. All right. So we have two types of transformations. Okay. The first one is called a rigid transformation. Okay. What that means is that the graph only changes position. Okay, it doesn't change size or shape, it only changes the position. Okay, then the second one we have is called a non-rigid, non-rigid transformation. And what that is, it changes the size and shape of the graph. Okay, so it could get bigger, it could get smaller, things like that. Rigid doesn't change the size and shape. It just changes the position, and non-rigid changes the size and the shape. Okay, so those are the keywords you have to remember for these type of transformations. All right, so let's look at the first ones. And once again, these are just charts from the book. You can use these as a reference, but I will explain everything to you in the slides following the charts. All right, so first one we're going to talk about is called a translation. Okay, translation is a rigid transformation, so it does not change size or shape. So a translation is a rigid transformation that has the effect of shifting. Okay, I'm going to highlight the important words. It shifts the graph of a function up, down, left, or right. Okay, so a translation is going to move it up, down, left, or right. So there are our four types. All right, so here is the general form of what we're going to look at. So y equals f of x. Okay, so let's just say we have y equals x squared. All right, so there's our equation. So if we take our function and we add a number after it, so for instance, y equals x squared, and we add a 3 after it, okay, so this plus k is going to make our graph move up. All right, so whatever the number is, it's going to move up. And then if we take our function and we subtract something after it, so for instance, y equals x squared minus 3, our graph is going to go down, okay, by whatever the number is. And then now we have right and left. So now this shows us that if we take our x and we add a number to it, okay, so let's say x plus 3 squared. See how we've taken the 3, instead of doing the 3 and the negative 3 after the function x squared, we're actually adding the 3 to the x. This is going to make our graph move left. Okay, so if we take if it's plus 3 attached to the x, it's going to move left. If we take our x and we subtract a number to it, so for instance, x minus 3 squared, the graph is going to do the opposite. It's going to move to the right. All right, so there's a difference here. If we take our full function and then we put a number at the end, plus 3 will move up, minus 3 will move down. And then if we take the x and we add a number directly to it, it's going to move it to the left and to the right. All right, so let's look at some examples. All right, so this is what we kind of just did. All right, so here are examples of translations. All right, so our parent function is y equals x squared. And if we take the x squared and we add a 6 after it, this is going to move our graph up 6. All right, so let's look at the graph and let's see what we have here. So we have x squared graphed, and then I'm going to do x squared, and then I'm going to add 6 to it at the end. So this should move our graph up 6. So there's our function, and then look. So it moved up 1, 2, 3, 4, 5, 6 tick marks up. So it moved our parabola. It just shifted our graph up 6. All right. So now if I take this, and if we look at our next one, it says minus 2. Let's see what that's going to do. If we take minus 2, it should move the whole parabola down 2. So here's our original. And notice that it moved it down. Took that whole parabola and moved it down 2 tick marks. All right. So this one right here moves our graph down 2. Now let's see what happens if we say x plus 2 squared. So I'm going to get rid of this one. Okay, so we still have our parent function y equals x squared. Now we're going to add a number directly to the x. So let's say plus 2. And then we're going to square it. So we've taken our x and we've added 2 directly to the x, not the whole function like the x plus 6 and minus 2. We're going to add it directly to the x. So let's see what this does. So there's our parent. And then notice that the whole parabola shifted 2 spots to the left. All right. So a plus 2 makes our graph go 2 to the left. Now, I'm assuming you know what the minus 4 is going to do. So let's take that. Instead of doing, we're going to do minus 4. Okay, so let's see what that does. There's our parent, our normal, and then minus 4 is going to make our parabola. Now it's going to go to the right by whatever the number is. So minus 4 is going to make our graph go right 4. All right, so there's some examples. So that's how you can tell translations, up, down, left, and right. All right, so now we're going to do another rigid transformation. We're going to do, it's called reflections. So here's the book chart. We're going to do our own now. A reflection is a rigid, okay, another rigid transformation which produces a mirror image of the graph. So you can kind of understand what a reflection is. If you look in a lake, you'll see your reflection, but it's a mirror image, so it's backwards. All right. So let's see what we have here. Here's our parent function. Okay, so let's do x squared again. Let's just do y equals x squared. Now, if you take your whole function and you put a minus in front of it, so for instance, we have our x squared, but we're going to put a minus in front of it. Okay, we're going to see that that is a reflection over the, oops, I'll just space these out a little bit. Okay, that is going to be a reflection over the x-axis. Okay, and if the second one, if we take but we only put the negative on the x. So notice that the negative is just attached to the x. So negative x squared, that should be a reflection over the opposite one, reflection over the y-axis. Okay, so let's look at some examples here. So if we have y equals x squared and we're making the whole function negative, let's see what it does to our graph. So we're going back to our calculator, and I'm going to delete this. So let's take negative, and then let's put x squared. So if we're taking our whole function, we're making it a negative. Let's see what it does. Okay, there's our function. Notice it flips it over the x-axis. So if we make our whole function negative, it's a reflection over the x-axis. Okay, and now let's do the opposite one. Let's make just our x negative. So I'm going to get rid of this. I'm going to get rid of this. I'm going to make just our x negative, so negative x. All right, so let's see what this looks like. Or I could put the squared on the inside, but it'll do the same thing. So here's our parent, and then notice can't see anything. Okay, so because it's reflecting it over the y-axis, the left and the right just flip-flop sides. So I'm going to change this to show you what it looks like. I'm going to change it to, let's change it to the darker line. Okay. All right, so here is the new graph. So here's the parent, and now look at the reflection. Oh, it just flipped it over, so it's reflecting it over the y-axis. So nothing is changing because it's a symmetrical parabola. All right. So that is the difference. So if we make just the x part negative, it is a reflection over the y-axis, but because it's a parabola, it's a little bit harder to look at because it is symmetrical. All right. Let's see here. All right, last one. We have the vertical and horizontal translations. So this chart is just the book chart. We're going to see what this looks like now. So a vertical or horizontal dilation. Okay, dilation is a non-rigid, so it is going to change the size and shape. That has the effect of compressing or shrinking or expanding, stretching the graph vertically or horizontally. Okay, so we have a vertical dilation Okay, this is going to make our graph go up and down. Oops, not that. Okay, it's going to stretch it or shrink up and down. And horizontal dilation is a stretch or a shrink left horizontally. All right, so let's see what we have here. So we have our parent function. So let's say it's y equals x squared. And now for vertical, you take the whole function, x squared, and you're going to multiply it by some number. Okay, so we're going to call that number a. And for a vertical, you're going to multiply just the x by that number. Okay, so it either goes inside the parentheses or on the outside. So let's see what this does. So here's our examples. All right, so we have two examples here. So we have two vertical. So the top two are vertical. Okay, so let's see if we can see what this does. So now let's take our function and multiply it by 3. So we're going to take our whole function and we're going to multiply. Let's change it back to normal though. All right, so there's normal. So we're going to take our whole function and we're going to multiply it by 3. And we're going to see what that does. Okay, here's our parent. And here is our new one. So basically what it's doing is it's taking our original parabola and it's stretching it up vertically. Okay, so it's making it skinner. So imagine taking a baseball or a basketball and taking the top and bottom and stretching it out vertically. Okay, so that's what that does. So if our A is bigger than 1, so notice we have our A is 3, it is a vertical stretch. Okay, and if our A, in the second one, if our A is between 1 and 0, so 1/2 is between 1 and 0, let's see what it does. So we're going to do 1/2 times x squared. So instead of 3, let's do 0.5 x squared. So let's see what this does. So here's our parabola, and what it's doing is, imagine taking a basketball and we're stretching it out vertically. So that's what that does. It's a vertical shrink. It's stretching it, and we're depressing the basketball like this. It's going to make the basketball go out wider. All right. So that's a vertical shrink. Okay, it's shrinking it. Okay, so when we take our whole function and multiply it by a number bigger than 1, it's a vertical stretch. And if we take our whole function and we multiply it by a number between 1 and 0, it's a vertical shrink. All right, so now let's go do the last two here. Now we're taking our x and we're multiplying it by a number. So if the number you're multiplying by x is bigger than 1, let's see what this does. So let's do x squared, and then we're going to get rid of this. Let's take 4x squared. Let's see what this does. Here's our parent. Oh, what's it doing? What it's doing is it's taking it and it's smushing the basketball horizontally inward. Okay, so it's horizontal shrinking. All right, so when A is big, when you attach a number directly to the x and it's bigger than 1, it is called a horizontal shrink by the reciprocal. So it's really shrinking it by 1/4. Okay? And then last but not least, when your A is between 1 and 0, like this one, 2/3. Let's see what this one does. Oops, I don't want that. So instead of 4, we're going to do 2. Let's do 0.66, since that's a little bit easier. 2/3 is 0.66. And we're going to graph. So there's our parent function. And you notice it makes it wider. So we're stretching. So when that number is between 1 and 0, we're stretching that basketball out widthwise. So we're making it horizontally bigger. So this is called a horizontal stretch by the reciprocal. So what's the reciprocal? 2/3 by 3/2. So we're making it 1.5 times bigger is what we're doing. All right. So that's section 1.5. Those are the different types of transformations that we talked about. Some are rigid, which only changes position. And then the last one we just did is non-rigid, which means it changes its size and shape. So either stretching it out or vertically stretching it out. Okay, we'll talk more about this tomorrow. Have a good night.